Hello, good morning, students. So, resistance of a conductor. If I am going to consider resistance of a conductor, generally a conductor resistance increases with length. A conductor resistance decreases with the area of cross section. So, by combining these two, we are going to write L by A, and one constant will enter, that is rho L by A. So here rho is the resistivity. So resistivity, remember my dear student, here resistivity does not depends upon the physical quantities involved in the formula. The physical quantity involved in the formula. Why? Because resistivity is a proportionality constant. Resistivity is a proportionality constant. So similarly, here no effect of L and A on rho. So whatever may be the length, whatever may be the area of cross section, resistivity won't change. Here resistivity is the proportionality constant. That's why what happened? No effect of L and A on rho. So that's why resistivity is independent of length and area of cross section. So this is the resistance. So here resistance depends upon four factors. One is material of a conductor. Second one is temperature of a conductor. Third one is length of the conductor. Fourth one is area of cross section of the conductor. But resistivity depends upon only two factors. One is material of the conductor. Second one is temperature of the conductor. But resistivity does not depends on length and area of cross section. Why? Because this is the proportionality constant we are going to getting in this formula. Similarly, in V is equal to IR also, R is the proportionality constant. So that's why remember no effect of V and I on R. No effect of V and I on R. Why? Because this is the proportionality constant. R is the proportionality constant. So this is about the resistance of a conductor. Resistance of a conductor. Now, in resistance based problems, sometimes they are going to use the word a wire is stretched. A wire is stretched. Suppose stretched wire. If I am going to consider a stretched wire. In stretched wire, suppose information given only about area. So, stretched wire means what will happen if I am going to stretch the wire? So, length increases, area of cross section decreases. Both will happen at the same time. But what happened in the problem? He won't give the both informations. So, he will give the information about area or information about length. Then how to solve the problems? Let us see. Suppose information given only about area. Only about area. At the time, how to solve the problem? After stretching wire, which quantity is constant? Volume is constant. Length changes, area of cross section changes. If length increases, area of cross section decreases. If I am going to stretching this wire, what will happen? If I am going to stretch this wire in this manner, this is the L1 means this is the L2. This is the A1 means this is the A2. Clearly we can understand L2 is greater than L1 and the A2 is less than A1. If length increases, area of cross section obviously decreases, no doubt at all. But here information given only about area of cross section. Even though length and area of cross section varies, one quantity is constant, that is volume. Here volume V means here also volume V. So if you are going to consider this its volume V1, its volume V2 means V1 is equal to V2. Volume won't be changed. So based on that logic, we are going to solve the problems. Information given only about the area of cross section or about only area. Area means area of cross section. Area of cross section. At the time, how to solve the problem? So R is equal to rho into L by A. We know that formula. Information given only about the area of cross section means numerator and denominator just multiplied with the area of cross section. Then what we are going to get? Rho times L into area of cross section volume, length into area of cross section volume. That is only I wrote as a V here, volume. A into A square. Resistivity, rho constant, volume constant. Then R and A both are inversely proportional. That's why resistance is inversely proportional to square of the area of cross section. This is the required relation for the stretched wire if information given only about the area of cross section. Then from this relation, how to write the formula? R1 upon R2 is equal to A square is inversely proportional. That's why A2 by A1. Why? Because it is inversely proportional and there is a square. That's why I write down the square. This is the required formula to solve the problems when stretched wire. For the stretched wire, if information given only about the area of cross section. Note down, students. Suppose information given about only radius. Only about radius. Then how to solve the problem? Already we have the relation R is inversely proportional to A square. Now only we proved, student. From here, R is inversely proportional to A means area means pi R square. Then A square means pi square R to the power of 4. Then pi square constant. Then R is inversely proportional to radius power 4. Then what we are going to get? This is the relation between resistance and radius. R is the resistance. R is the resistance of a wire. Relation between resistance and radius. R is equal to radius of a wire. Then this is the relation. Then what is the formula? R1 upon R2 is equal to R power 4 inversely proportional. That's why R2 by R1 whole to the power of 4. This is the formula to solve the problem. And if suppose he is given diameter, then how to solve the problem? We know that d1 by d2, diameter of the first wire by diameter initial case by diameter final case. Diameter before stretching, diameter after stretching. So is equal to diameter means 2 times radius, diameter means 2 times radius 2. 2 to cancel. That's why my dear student, diameter ratio, radius ratio always same. That's why in place of R2 by R1 replace the D2 by D1. If suppose D1 by D2 is equal to R1 by R2, similarly R2 by R1 is equal to D2 by D1. Like that, in terms of diameter, what is the formula? R1 upon R2 is equal to R2 by R1, replace with the diameter, D2 by D1. R2 by R1, so D2 by D1 whole to the power of 4. If a diameter only given, use this relation or this formula to solve the problem. My dear student, note down. For stretched wire, information given only about length. So, why? Because for stretched wire both will change, area and length. But volume constant. E is given only information about length. Then how to solve the problem? Information given only about length of the wire. Only about length of the wire in the problem, in the given problem, of course. At the time, what is R is equal to? Rho into L by A. If information given only about length means in this formula, numerator and denominator on right hand side multiplied with length. At the time, R is equal to rho into L times L square upon area into length, volume. Area into length is equal to volume. In this case, resistivity constant, volume constant. Then R is proportional to L square. This is the relation between R into that means resistance. R is the resistance. R is the resistance, L is the length. This is the relation between. This is the relation between resistance and length. Resistance and length. If only length given in the problem for the stretched wire. So what is the formula now? R1 upon R2 is equal to L1 upon L2. Directly proportional, no? That's why. Then there is a square. That's why whole square. This is the formula we are going to using to solve the problems for stretched wire in case of information given only about the length. Thank you, student.